Hi everyone, my name is Limin. Today I'm going to present about my final year research project on aerodynamic optimization of prototype hovercraft through biomimetic approach. This research project is supervised by Dr. Chong Kok Hing. First, let's start with the project background. Hovercraft is an air-cushioned vehicle which is capable to travel on different surfaces such as land and water by the lifting force created under the hull. A hovercraft works by trapping an air cushion under the hull to create a pressure that lifts the hovercraft. The presence of drag increases the force needed to drive the hovercraft forward, hence increases the fuel consumption. Based on my research, more than half of the fuel energy is used to overcome the aerodynamic drag of a vehicle. Also, biomimetic approach is yet to be introduced in hovercraft to optimize its aerodynamic performance. Therefore, the aim of this project is to propose an improved design of hovercraft in terms of aerodynamic performance through biomimetic approach. The research questions are: what biological structures are suitable to be implemented in designing a prototype hovercraft with optimized aerodynamic performance? What are the optimum dimensions for prototype hovercraft for better drag reduction and aerodynamic performance? And what skirt designs can be implemented in the prototype hovercraft in reducing the skirt drag? The objectives of this research are to study and determine the suitable biological structures that can be implemented to the hovercraft, to determine the optimum dimensions of hovercraft for better drag reduction and aerodynamic performance, and to determine the skirt designs that can be implemented to hovercraft for drag reduction purpose. Now, let's move on to the literature review. It will be discussed in three sections: hovercraft, skirt design, and biomimicry. The average speed of a commercial hovercraft can reach to about 56 km per hour. The dimensions of a small capacity hovercraft that can occupy 1 to 2 people is around 3 meter long and 1.5 meter wide. The diameters of lift fan and propeller are 61 cm and 91 cm respectively. These dimensions will be used as a reference for the 3D modeling of hovercraft. The next part is the skirt design. A skirt is an airbag that is attached to the hull of a hovercraft and is usually made of materials that are waterproof, lightweight, non-breathable, and robust. There are three types of skirt design, which are back skirt, segmented skirt, and hybrid skirt. A back skirt can be simply thought of as a round tube fitted around the hull of the hovercraft. Back skirt has a good stability and durability. However, it has high drag on undulating surfaces. The segmented skirt consists of many separate segments fitted around the hull of the hovercraft. Segmented skirt offers low drag coefficient on rough surfaces, but it has poor stability and durability, and can be easily damaged by obstacles when traveled on rough surfaces. A hybrid skirt is a combination of back skirt and segmented skirt. It has excellent stability and durability, as well as moderate drag on rough surfaces. It is usually used in large hovercraft as it is expensive and complicated to make. Next, biomimetic approach is an approach that involves understanding and imitating the structures from the nature into engineering design. For example, the streamlined body shape of marine animals such as penguin and boxfish can minimize the drag coefficient. Tubercles on the flippers of a humpback whale can reduce drag by 32% with 8% lift improvement. A well-known example of biomimicry is the Shinkansen bullet train, which its front end is inspired by the kingfisher's beak. This bio-inspired structure has reduced the electricity by 15% and increased the speed by 10% with lower noise produced. Next, methodology. The process of my research project is illustrated in the chart. First is the research on the background and relevant knowledge about hovercraft and biomimicry. Then, the 3D model of prototype is drawn using SolidWorks, followed by material selection for the prototype. Next, the biological structure will be incorporated into the prototype, and the flow around the prototype will be simulated using SolidWorks flow simulation. If the result is not satisfying, I will move back to the previous step to select another biological structure until the aerodynamic performance is optimized. The expected outcome of my project is that biomimetic approach is successfully implemented into hovercraft so that reduction in drag and fuel consumption of hovercraft is achieved. For future works, I will explore more bio-inspired structures and provide more designs for better drag reduction in hovercraft. I will also perform finite element analysis to simulate the stress of the hovercraft. So that's all for my presentation. Thank you.